Okay, this is the last section of chapter 18, which is on blood, and we're going to be talking about hemostasis. Hemostasis is the process of blood clotting, and it requires various things. It requires calcium ions, it requires clotting factors, it requires platelets, as well as vitamin K, as we will see at different stages of blood clotting as we're talking about this. The platelets that I've mentioned, we've already talked about platelets. Platelets are formed elements that are formed from megakaryocytes during hemopoiesis. And so if you forgot how that was done, make sure that you refresh that information on how they are formed. But they are basically chopped off from the megakaryocytes by the blood flow. The platelets are stored. The platelets are found in your blood, and they're also stored in your spleen. About 30% of platelets that are in your body are actually stored in spleen. So we say that spleen is the largest reservoir of platelets in your body. Platelets do not live forever. They're not in your body forever. They're going to degrade, but your body always forms new ones. Platelets live for about 8 to 10 days, so a much shorter lifespan compared to erythrocytes that this formed element has. So let's go ahead and focus on the stages of hemostasis, or stages of blood clotting. There are 3 main stages of blood clotting, and they include vascular spasms. That's stage number 1. Stage or phase number 2 would be platelet plug formation. And then the last stage is going to be the coagulation phase. So we're gonna now look at the image that goes with your textbook, so that we kind of have a little bit of a visual as we're talking about this. Okay, oh, I have to do this. All right, so that should work now, maybe. Okay. So hopefully you are all seeing this image right now. I don't know where you guys see me, but hopefully everybody is able to view this image. This is figure 1812 from your textbook. And so we're just gonna be kind of referring to this as we're talking about this. So the first phase of hemostasis is vascular spasm. So hemostasis is initiated whenever a blood vessel is damaged. So some kind of damage occurs to the blood vessel, and the blood vessel is broken and blood starts escaping from the blood vessel. So vascular spasm is initiated right after that blood vessel injury, and this is to prevent loss of blood from that blood vessel. So that makes sense. You don't want it to keep bleeding and you're losing a lot of blood. So that vascular spasm, that's basically all we're going to say about that. Okay, it's just when the vessel is injured, it constricts, and that limits the blood loss. Another thing that happens actually whenever right after the injury to the vessel is that collagen fibers are exposed, and this is an important part of the second phase, which is which is the platelet plug formation. So normally when your vessel is healthy, it is lined by prostacyclin, and prostacyclin is this just internal lining of the blood vessel that, in all essence, prevents platelets to stick to the vessels of the wall. If the vessel is not damaged, platelets don't need to be sticking and forming platelet plugs randomly in your vessels, because that would prevent blood flow, right? But whenever the blood vessel is damaged, you expose those collagen fibers from the broken tissue, and you also interrupt the lining of the prostacyclin in that area. And so what's going to happen is that there are, where was I? Sorry, my notification kind of disturbed me there. I'm sorry. I have to, this is the first time I'm actually mirroring my iPad here to you this way. And so I will have to remember to turn those notifications off. Okay, so when the collagen fibers are exposed, what the platelets are going to do, since the prostacyclin lining is damaged, is they're going to start sticking to those exposed collagen fibers. And one thing that actually helps with this is going to be this this factor here that I forgot the name, von Willebrand factor, and that is going to help these platelets stick into the collagen fibers. Okay, so this factor is kind of like a link between the platelet and the collagen fiber. That's what helps them bind to those fibers. As these platelets are sticking to these collagen fibers, they are going to start transforming. So we say that they're transforming, and what that means is that they start releasing chemicals to the surrounding cells and also into the inside of the vessel. And these chemicals are going to do several things. They're going to cause the vascular spasm of the vessel to be prolonged. So they're going to maintain that spasm of that vessel. So they're stimulating those smooth muscle cells in the vessel to keep contracting and hold the vascular spasm so that we're not losing a lot of blood. They are also going to, these chemicals that are released by these platelets are also going to cause attraction of other platelets. So they're like releasing these chemicals and telling basically these other platelets, I don't know why my watch is talking to me, these platelets are telling them, hey, there is damage here. We need to start working at fixing this damage. Come and join us, okay? So they're like inviting other platelets to the party. And so this is a positive feedback, okay? The more platelets that stick there, the more of them transform, and the more platelets are attracted to the area to form that platelet plug. And when you think about platelet plug, that's exactly what that means. So look at that. See that, how they're congregating inside of that break, and they're filling that break temporarily, creating kind of like a plug. Well, it is a plug. And the other thing that these chemicals from the platelets are doing is they're going to stimulate coagulation phase, which is the next phase that is coming up. And also they are promoting a repair of the blood vessels. So this is all kind of promoting all these things that are going to happen down the line. So that is platelet plug formation. And then ultimately coagulation phase happens. And coagulation phase is the actual blood clotting. And we can see that here. So when the blood clotting is finished, you're going to see kind of a more stabilized clot, like a more solid structure in there that is, just more reinforced than just a platelet plug on its own. So the coagulation phase requires several things. It requires calcium ions, which are normally found in the blood. So this is the pathway that they're going to be used in. There are also platelets required, of course, for coagulation phase, and then clotting factors and vitamin K. So the clotting factors, there's a bunch of them listed for you in the textbook, and there's a nice flow chart actually that shows you the order of how the clotting factors are acting in these pathways here. There are two pathways that the coagulation phase can happen in. The intrinsic pathway is initiated by the damage from the inside of the vessel. And this takes about 3 to 5 minutes, okay? So our vessels do get worn out from the inside also. So sometimes there are small tears that happen internally, and that pathway would be about 3 to 6 minutes, 3 to 5 or 6 minutes. What happens here is that platelets adhere to the damaged wall. They're going to release factor 7, which then is going to activate factor 11, and then this activates factor 9. It's a bunch of factors here. And then that binds calcium and platelet factor 3. And what is kind of important, and let me see if I have that. So we're right here, okay? So I was talking about that platelet factor 3, so it would be kind of right here. That platelet factor 3 is then going to result in activation of factor 8, as we see here. And this factor 8 is inactive at this point, okay? But that's what we end up with intrinsic pathway. The extrinsic pathway, as you can see on here, is a little less demanding. A little less demanding on the factors here. So extrinsic pathway happens due to the damage from the outside of the vessel. So it's external damage, so extrinsic, external. And this takes about 15 seconds, so it's much, much faster. And usually external damage to the vessel involves more significant bleeding than internal damage, which is from various processes from the inside. And so here what you can see is that in the extrinsic pathway, thromboplasmin would be released here. It combines with factor 7 and then the calcium is going to enter here as well. And then so whether you start with the intrinsic pathway or the extrinsic pathway, we are going to then activate factor 10 here, okay? So if you start with intrinsic pathway, you're going to end up with factor 8, which will activate factor 10. Extrinsic pathway, you end up with that factor 7 and 3, and then they're going to activate that factor 10. So common pathway is going to begin with factor 10. No matter which pathway you came from, it's going to, common pathway begins with factor 10. Okay, then that factor 10 is going to combine with factor 2 and 5, and then calcium ions again are important here. And platelet factor 3 as well. And these all are going to activate prothrombin into thrombin, okay? Thrombin then is going to convert soluble fibrinogen, remember fibrinogen? Thrombin converts fibrinogen into insoluble fibrin. Fibrinogen was one of those plasma proteins that we talked about in the beginning of the chapter when we talked about components of blood plasma. Fibrinogen is an inactive soluble protein that is found in the blood plasma. But if the clotting phase is activated, of hemostasis is going on, then fibrinogen ultimately gets converted into fibrin, and it's thrombin that converts it into fibrin. And then this fibrin will then provide framework for the blood clot. Okay, fibrin is, after the fibrinogen is activated into fibrin, it creates fibers. And these fibers will kind of intertwine among or into the platelet plug that we saw formed. And then these fibers will provide the framework for that blood clot so that it is maintaining its structure. And so this is a positive feedback again. It builds upon itself until we achieve that final product, which is the blood clot. And I know it's a bunch of factors there, so try to find a way to maybe like memorize how they go in order. One other thing I maybe didn't mention in this pathway here, exactly, is that vitamin K is also vital to this process working properly. So if you are deficient on vitamin K, this pathway will not work properly, okay? So vitamin K deficiencies generally are marked by problems with bleeding. You would have bleeding abnormalities if you're low on vitamin K. Vitamin K is formed in our digestive system by our gut bacteria. So that's kind of that. So once we have this blood clot, it doesn't stay there forever, okay? Of course, we are going to eliminate this blood clot eventually, and we're going to repair the blood vessel. And so how this happens is that after, there are two processes actually that are going to be involved in the blood clot elimination, and they are clot retraction and fibrinolysis. Fibrinolysis kind of seems that I think that's kind of common sense. What that would be fibrinolysis. It's breaking down of the fibrin framework of the blood clot. And the clot retraction, what this means is that the platelets, they actually on the inside have a protein called actinomyosin. And you hear that myo in there, so that should kind of suggest that it's going to cause some kind of contraction here. So the actinomyosin, what it does inside of the platelets is it contracts, and what it does is it squeezes the blood clot from inside. And as it squeezes it, there's serum being squeezed out of the blood clot. Blood clot gets smaller and smaller. Now look at the picture of the blood clot here. Okay, you see it right here. Now imagine it that it's getting smaller and smaller. As it's getting smaller and smaller, it brings the walls of the vessel together. And this is also going to be promoting the repair of the blood, of the break in that blood vessel. Okay, so it brings the walls of the vessel together and promotes repair of the vessel eventually. Last part of the hemostasis part is the sympathetic response of or to blood loss. So what happens when you're losing a lot of blood? And so if you lose more than 10% of your blood volume, survival response is initiated in your body. There is autonomic nervous system that is going to activate increased vasoconstriction of the vessels, as well as increased heart rate, increased force of heart contraction, and this is all in order to maintain sufficient blood pressure. This will probably make a little bit more sense when we talk about the blood pressure and how this works. But adequate blood pressure is very important for maintaining appropriate exchange of materials between blood and your tissues. So if you lose a lot of blood volume, then you have less blood that fills up your blood vessels, and so your blood pressure drops. And for that reason, this our autonomic nervous system is going to increase vasoconstriction so that you increase blood pressure. Okay, so since you have less blood, now you have to make the vessel smaller in order for the blood pressure to be the same. Force of contraction is also the same. So you have less blood, so you increase force of contraction, as well as these notifications. You increase force of contraction and you increase heart rate. And this is also going to make the less amount of blood that you have circulate through your body faster. And it seems like it's kind of going backwards because you're bleeding. So why would you increase force of contraction? Why would you be increasing heart rate? That's just going to make you bleed out faster. But the idea is that your body is working on fixing this loss of blood. Okay, it's fixing this vessel. It is trying to fix the place where you're losing the blood from. Okay, and so for that reason, you are going to increase heart rate, increase force of contraction, and increase vasoconstriction, so that your tissues are not getting deprived of nutrients. You also might see redistribution of blood flow a little bit, so that it's redistributed to vital organs, and that's hemostasis. That's all from chapter 18, and I apologize for those notifications here. Again, this was the first time that I was sharing this, and it just occurred to me that I probably could have just turned on do not disturb, and I didn't do that. So I will make sure that I will do that next time for you and for me. So yeah, that's that for chapter 18. Let me know if you have any questions. I'm always here through email or post a comment on Google Classroom, whichever way. I'll try to get back to you as soon as I can.